Hello everyone, this is Miss Mills. I'm going to do some of the problems from the practice set to help you know what's going to be on the test for Module 3. Okay, so these are just different homework problems that will let you know what kind of problems are going to be on that test. Okay, so this is Module 3. Selected problems. All right. This one is for each graph, identify the domain range and whether or not the function is increasing or decreasing. Use interval notation when you state the domain and range. So I think if I'm seeing this correctly, this is where it starts. So that's going to be a square bracket, and it's going to go on forever. And let's see, as I am increasing my independent variable, my dependent variable is also going up, and it's an uphill. So this is an increasing, always increasing function. And the negative end, it would be negative infinity because it goes on forever, but it ends here. Let's see, here's 0. So I guess that's about negative 1/2. If I'm reading that correctly, and that was a dot. Oh, they didn't ask me for the interval of it. It's just increasing. The domain. Domain is my independent variable, my x, my independent. And so actually what I just did for increasing is the same thing as the domain. In the negative direction, it's negative infinity, and it stops where x is about negative 1/2. And the range, I'm going to write it up here because I want to fit it on this paper. And that's the possible y values, the dependent variable. So goes on forever, stops at 6. Let's look at the other one. Okay, this one also looks like it's increasing because as I move along the x-axis, my y also increases. So that's increasing. It has a point where it stops here at, this is kind of hard to see. I think that's a negative 5. And it's not right on 0. I'm going to say 1/4. And it stops there. Oh, I'm sorry. I was saying this is just the point. Negative 5, 1/4. And it goes on forever. So if I'm talking about my domain, I'm looking at my x values, and it starts at negative 5 and goes on forever, infinity. And if I'm looking at my range, that's my y values. It starts estimated 1/4. And let's see, up here it's going to keep increasing. It doesn't look like it's ever going to like turn in some other direction, so infinity. Okay, so what is the point here? You have to know how to find domain and range, and you have to know whether a function is increasing or decreasing. Okay, let's take a look at this one. So let me point some things out. Y-axis, here are our y-intercepts. I'm going to label them. Always for a y-intercept, x is 0, and this is 4, and this is 3. X-intercept, I don't have one here, but I have one here. And that's 1, 2, 3, 4, 5. Yeah, that's negative 3, so And where do they intersect? Right here. I think it's on 2, 1, 2, 3, 4, 5. Okay. Where does f of x equal g of x at 2, 5? Okay, these lines copied kind of light, so may have looked different in the book, but to me the closest I can see there is 2, 5. Then it's asking me what is f of 4 added to g of 4. So here's f of x. And here's g of x. And I just have to see if x is 4, this one is 6, g of x is 6, and f of x is 7. So that's all they're asking there, is to look at the graph, look at the line, identify the point on the line. This point was 4, 6, and this point was 4, 7. So f of 4 was 7, and g of 4 was 6. Just add them together. Okay, -2. It's right here. So -2, comma 1. -2, comma 3. G of -2 is 3. F of -2 is 1. 3 minus 1 equals 2. So you just have to make sure you do one step at a time. Don't try to say, oh, what's -2 minus -2? That's not what they're asking. They're asking you to look at your graphs, the line that represents those functions. State the interval where g of x is greater than f of x. So they cross here. So g of x is greater or higher up. This whole part up until they cross right here. So always from here on, it's always going to be higher. So that's -infinity. Sorry, make a good infinity symbol. And they crossed, where did I say they crossed? At 2, 5. So the interval is, when they're asking at me for the interval, they want to know the x value, so 2. Okay.